Hello everyone, in this video I am going to go over the homework for January 26th. So here are our instructions in the Excel file. There's three parts. We're going to use the age variable, the own laundry age variable, and the shoe size variable. So for the first one, we're going to select the age column and insert a histogram. To select the age column, just click the B over the column, and then we go to insert. And make sure you actually get the one called histogram, not the column chart. They look similar, but they are different. Okay, and make sure you get histogram and not the Pareto chart that is next to it. Okay, so histogram, it should actually say histogram when you hover over that button. Okay, let me move this off to the side a little bit so you guys can see. Oh, I need to make room here. Sorry. All right, so this is, I'm just going to title this so I don't forget which one is which. This is age from the class survey. All right, and now we are going to change the bin width to 1. So you're going to right click right on the numbers in the bins and do format axis, and then select bin width and change that to 1. Okay, so when we do that, it looks quite different. Let's see here. Now, I'm slightly confused because I thought there was someone who was 16 in this survey. Oh, I see. I have a filter on this. I'm sorry about that. I'll get rid of the filter before I upload this file. I had a filter. Ooh, where is it? You guys see the little filter icon right here? I was doing some filtering earlier for my own curiosity. Oh, and that was a sorting icon. Okay. Sorry. Yes, there were 16-year-olds because I've had some high school students in this class in the past. All right, so this is how it should have looked. So the first bin here is from 16 to 17, and we have square brackets around it, so it does include both 16 and 17. And if you hover over this, you see it says value 9. That means there were 9 respondents who were 16 or 17. And then the next bin here is from 17 to 18, but it does not include 17. So the round endpoint with the round parenthesis is not included. And the square bracket side, that is included. If you guys want to know a really dumb, and I mean really dumb, way of remembering the round versus the square, I like to imagine one of those like claw machines, like at, I don't know, like at the movies or whatever, where you can like try to pick up the stuffed animals. And I think a square shaped claw, to me, it looks like a more effective claw for picking things up with. That is how I remember that the square side is included and the round side is not included. I think the round claw would drop a lot of things. Okay, that's really dumb, but I've never found a better way of remembering it than that, and I'm not convinced that that is not the actual motivation for why they were chosen. So anyway, so in other words, this column here that has 105 people in it is only including the 18-year-olds, unless somebody said that they were 17.5, but I don't think they did. So this is all the 18-year-olds. So that was the most popular category, and then the 19-year-olds are here. The 20-year-olds are here, the 21-year-olds are here, and then there's a couple of more older people. Okay, so describe what the histogram is telling you about the ages of the students who have taken the survey. So I'll just write a sentence or two here. There were a few people aged 16 to 17, but the most popular age was 18 with more than 100, how do I spell 100, students. The second most popular was 19. There are only about 20 people aged 20 or older. The oldest was, looks like the oldest was in the category that only has 23 in it. Okay, that's a kind of a long summary. I mean, yours doesn't have to be this long, but that's everything I see pretty much. Question 3 Is the histogram unimodal, bimodal, multimodal, or none of the above? This is definitely unimodal. So there's one column that's clearly taller than the others, and the other column from the right, they kind of like lead up to it. From the left, it's not so much of a lead up, it's more like a cliff. So this is definitely unimodal, meaning one popular category. Is the histogram skewed left, skewed right, or symmetrical? It's not symmetrical for sure. You can see if we swap it from left to right, it'll look really different. So the skewed direction refers to where the longer, fatter tail is at. So I would say starting from the 18-19 category, this column, this column, this column, this one, and this one, that's the tail. And it's pretty fat or heavy because this one is so tall. And yeah, it's pretty long as well. Whereas on the left, we do have a left tail over here. It's just this one column, and that's really short tail. So the tail, the larger, fatter tail is towards the right, so that is skewed right. Right. Oop, there we go. Okay, are there any obvious outliers? No, not really. Everybody's kind of within a normal, like, college age range, I would say, in high school. Maybe if there'd been someone that was like 30 or something, then that would be an outlier. Usually with an outlier, you want to see a gap. So even though there's a couple people here that made these last two bins really short, there's not really a gap between them and the other students. It's like trailing off in a kind of getting shorter and shorter, but there's no gap. Okay. So part B is for own laundry age. So we're going to select the own laundry column and insert a histogram. So let me do that. It's all the way on the right. I personally think this is the most interesting column for what it can tell us about the students, and I'll tell you why in a second. So I'm going to cut that. I just did Control X to cut it, and I'm going to come over here, like right around here, Control V, and put it in so we can look at it side by side with the instructions. Okay, so we're going to try some different bin widths like 0.5, 1, 1.25, 1.5, 1.75, and 2. And we'll just see what we see from that. Let me actually put a title on this too so I don't forget what I'm doing here. So this is own laundry age, and this is from the class survey data. All right, so now let's try some different bin widths. Do this again. Okay, so I'm going to try a bin width of 0.5 first of all, and there's actually a question about this bin width as well. So you see it kind of looks like piano keys or maybe like broken teeth or something. So the question here is, why does this bin width show so many gaps between the bins? In other words, why are there gaps between the columns that have anybody in them? So if you look carefully at the bins that don't have any respondents in them, for example, there's this one from 11 to 11.5, but it does not include 11 because that has the round parenthesis next to it. So to get in this bin, you would have had to have answered like 11.5 or 11.25 or 11.1 or something like that. But everybody who answered this survey put a whole integer for their answer, so there's nobody in this bin. Yeah, so basically it's just explained by the fact that everyone gave whole numbers, and we just set the bin width to be less than a whole number, right? So like there's gaps between whole numbers. Like that's just pretty much what this is showing. It's showing the gaps between the whole numbers. So I'm just gonna write that down. Everyone answered a whole number, and 0.5 is less than a whole number, so this is showing the gaps between the integers. Okay, hope that makes sense to you guys. Typically, even if everybody didn't answer with whole numbers, there will be some like small enough bin width that would show gaps between people's answers anyway, because most people are not going to answer with like a whole bunch of decimals. Yeah. All right, so anyway, let's try the rest of these bin widths and see what they look like. So 1 should probably look much more reasonable. All right, bin width 1, hit enter. Yeah, okay, this looks more reasonable. So now each interval here is going to have basically one age in it, because, for example, this one, even though it goes from 13 to 14, it does not include 13. So this will be just the people that were 14, basically, in this category. And so now you guys start to see what's actually interesting about this laundry age thing, is it's like there's this cohort of people who started doing their own laundry at 12. That's like very popular. And then there's this other group over here that started doing it at 18, so when they went to college. And what I keep always wondering about is like, well, it's kind of interesting. Like, you think about the parenting style, like, well, some families are like, yep, start doing it in middle school, and then some families start doing it in college. And I don't know why there's such a difference. There's also like kind of smaller group that started doing it even earlier than 12. And then of course there's a whole bunch that were like somewhere in between, I guess. These people that started at 19, maybe they went to college a little bit, or they were like a little bit older than their classmates and they were 19 when they went to college, I guess. Probably. Or they convinced their freshman roommate to do their laundry. Okay, the rest of these bin sizes, let's just see if it keeps looking like this as we go up through some other bin widths. 1.25. Okay. 1.5. All right, so now we're actually seeing like a tri-modal kind of thing at 1.25 and at 1.5. Yeah, that's interesting. That might sort of be to do with the way these bins are. Like, so for example, if you look at this bin, 14.75 to 16. So this includes 16 and it also includes 15. Whereas this bin right here would only include, for whole numbers, this would only include 14. So I think this is like a little bit just an artifact of kind of the way the integers were spread amongst the bins. This like extra mode that appears. That is interesting. From a mathematical perspective, that's interesting to me. In fact, maybe that makes me want to change what I asked you guys to do over here. Maybe I'm going to ask you guys to use the bin width of, to use the bin width of 1 instead of 1.25. I think that makes more sense for these questions. Okay, so I'm going to ask you about the bin width of 1, and then we can try some of these other bin widths as well. I would say if your answers are all integers, then bin widths between integers don't make a ton of sense. Probably whole number bin widths make more sense, like 2 or 1. Yeah, when we go to 2, we do see it's bimodal again. We have this group that started in middle school over here, and then we have the group that started in college, and we have some lower numbers that started at the ages in between. Okay, so I'm going to set it back to a bin width of 1 and answer these questions over here. All right, so using a bin width of 1, write 1 to 2 sentences describing what this histogram tells you about the age that respondents started doing their own laundry. Okay, so I'm just going to tell like a whole little story here. So there are a few respondents that started ages 6 to, like this little region here, 6 to 9. Well, maybe I'll just go all the way from 6 to like 11. Then a large group started at age 12. The majority started between 12 and 17, and then another large group started at 18. The most popular age was 18. A few started at 19. Okay, that's a pretty long description. Is the histogram with bin width 1 unimodal, bimodal, multimodal, or none of the above? I would say this is bimodal. It's got 2 clear peaks. You know, there's also these in the middle that are like a little bit peaky, but I don't think that's quite far enough from the other heights. It's these 2 that are really the big peaks. The middle school starters and the college starters. Okay. Oh, maybe, you know what? Maybe this is like coming from starting high school. Did some people start like right around when they started high school? Maybe. I don't know. Okay. Um, Bimodal is probably the closest match. Peaks. Oh, it's not letting me type. 12 and 18. Okay, is the histogram with bin width 1 skewed left, skewed right, or symmetrical? So it has tails. It has a left tail here, and it has a right tail, very short right tail over here. So the longer, fatter tail is to the left. So that is skewed left. So if we were to take the average, it would be dragged down by that group of people who started before middle school, whereas the median would probably be kind of firmly in the high school range. Okay, skewed left. Obvious outliers? No, I don't think so, because this smallest category, 6 to 7, like there's 5 people in it, so that's kind of popular. So no outliers that I see. Okay, shoe size. Select the shoe size column, insert a histogram. So back up here to column F, insert histogram. And I'm going to cut this again, Control X, move it down here, next to the questions. Okay. And let's call this shoe size so I don't forget. Okay. Right, change the bin width to 1. All right. Some people did answer with 0.5 for their shoe sizes, but 1 is a good bin width anyway. Okay. Write 1 to 2 sentences describing what this histogram tells you about the shoe sizes of the survey respondents. Okay, well, it's pretty clear. There's like a big lump in the middle, right? Just a few people to the sides. So I'm just going to talk about that. So most people's shoe sizes were from, this is not updating my writing. Let's see, where does the first kind of tall column start at? So this column here, this is from 7 to 8. It does not include 7. So the first shoe size that would be in this column would be 7.5. So I'm going to say these are from 7.5 to the last kind of actually popular one. Should I go with this one or this one? I guess this one. So this stops at, and it does include 13. So we'll say to 13 with just a few people outside that range. And then within the like 7.5 to 13 range, like these are pretty uniformly distributed. Maybe it's tailing off a bit to the right, but with these 2 columns, but like these 4 are pretty solidly equal in popularity. So you could mention that as well, or you could just stop with this sentence here. I mean, I think this would be fine. Right. Question 3, is the histogram unimodal, bimodal, multimodal, or none of the above? It's a little bit hard to say because it is so flat across the top. I would say you could either say it's unimodal with a mode kind of like around here, around 11 or 10 to 11, or you could say it's none of the above since it doesn't have a clear like point. I think I'll go with none of the above. No clear peak. Is the histogram skewed left, skewed right, or symmetrical? Ooh, it's pretty symmetrical. I mean, you could say maybe this is the start of the left tail and so that makes it a little bit longer than the right tail, but I mean, you could say this is part of the right tail, so it's kind of, it's a bit iffy. It's pretty symmetrical, I'd say. You'll never get like a perfectly symmetrical one anyway. This is about as symmetrical as it gets. Would you describe the distribution as uniform, bell-shaped, or neither? It is actually like pretty bell-shaped, I think. It's not like a perfect bell, but yeah, I mean, it's got the skinny tails on the left and the right. It's basically symmetrical. and it's got that kind of hump in the middle, a little bit of curve, not quite enough curve on the sides of the lump, but you'd like them to be a little more S-shaped, but that's pretty close to bell-shaped, I'd say. So this is close to bell-shaped. And that's actually like kind of typical thing to see from physical size measurements, like shoe size or height. It often does come out with that bell shape like that, which we'll talk about why that is later. All right, so that's it for today's homework, and you'll take a quiz on these topics next time.